Welcome to the B Toppers class. We will start the 8th class physics by looking into one of the most fundamental aspects of sciences, that is measurement. Now before we directly go into the topics, let us look at the various situations in day-to-day life in which we need measurements. Suppose early in the morning you want to have a hot cup of Bournvita or Boost or milk. If your mother gives you a jug of milk, you will not drink it. You will say that, no, give me in that glass, because that is the glass that you are used to drinking in daily. So there is a certain amount of measurement there. You don't want more than that. You don't want less than that. Then, if you are getting late to the school, every now and then you will be glancing at the clock and you'll say, oh my God, I'm going to be late at the school. So there is another measurement there. Intuitively, you know that if you start by 7:30, you will be able to reach the school by 8:15 and so on. So there is some measurement involved there. Then, in that hurry, if you have to fill up your water bottle, based on your day-to-day experiences till now, you might be having an idea that, okay, my water bottle can contain 3 full glasses of water. There is another measurement that is involved there. And then, once you reach the school, for example, in your maths class, you might be asked to draw a rectangle, you might be asked to draw a triangle or a circle with a specific radius, a certain length, a certain breadth, and so on. Therefore, from the moment you got up, when you looked at the watch and you thought that you might be late to the school, to this situation where you actually are in the school and you are required to draw something there, measurement is there in every aspect of your life. Then suppose you have your games period. You want to find out as to which of your friends can run faster. So when you say you want to find out which of your friends can run faster, it means you will be looking at your friends, you will be looking at your watch, you will be saying that, okay, you run from this tree to that tree and I will measure the time. So you see there is measurement involved everywhere, from maths class to the games period. But of course, you will not be satisfied only with the games period. After you come back home, you would like to watch a cricket match. There, suppose a bowler appeals for an LBW. The umpire will refer it to the third umpire. He'll say something like this, and the decision will be referred to the third umpire. There, you see what they use is what is called the Hawkeye. Hawkeye measures the line of the ball, the length of the ball, and whether it is going to hit the wickets or not. There is a very complex calculation involved in that, and all the calculations there require measurement. Otherwise, you don't know where the ball is landing. You don't know in which direction the ball is going to swing. Therefore, measurement is involved everywhere. And after every over, they show you this another Hawkeye kind of a screen where you see how many balls were actually going to hit the wicket, how many balls were going to go over the wicket or towards the left-hand side or towards the right-hand side. So from the instance you get up in the morning to your activities at school, your activities at games and watching TV, measurement is involved everywhere. Now, intuitively or from our day-to-day life experiences, we have an idea of what is meant by measurement because we are using measurement in day-to-day life activities. But once we try to analyze that conceptually or from the point of view of science, you need an exact definition for measurement. So what is measurement? Scientifically, determining the ratio of a physical quantity to a standard reference is called as measurement. So as you see in this definition itself, there are 2 points involved. First one is choosing a standard reference. There is a name to this reference. We will come to that later on. But the first step is choosing a standard reference. And once you have chosen the standard reference, you have to compare the given quantity to the standard reference or to the reference. This entire process is known as measurement. The best way to understand this is to take up an example. So let us take up an example. Suppose you are asked to compare the lengths of 2 bars, and the question that is posed to you is which of these 2 bars is longer and by how much? Now there are 2 parts to the question. First one is which of these 2 bars is longer. You don't need a big scientific technique for that. Just by looking at that, you will be able to easily say that B is longer than A. It's as simple as that. But it is the second part of the question that is slightly tricky. By how much? For that, we will have to get into the act of measurement. So you take the bar B first. Then what you do is you place a bar A there. And are the lengths equal now? They are not. So you place another one identical to that. So now you have used up 2 bars. Are the lengths equal still? No. Then you put the third bar. Then you see that the length accommodated by 3 bars of A is exactly equal to the length accommodated by 1 bar of B. So now you can confidently say that the bar B is 3 times longer than the bar A. I hope this example is clear to you. This is the simple example that will make you understand the concept of what we called as a unit. So in the previous example, we saw that we had taken bar A and bar B. Similarly, a standard reference of a physical quantity is what is called as a unit. So in the first step of measurement, if you remember, I said that you have to choose a standard reference. That standard reference is called as a unit here. So if you look at the previous example where we were trying to compare the lengths of A and B, you wanted to see how many lengths of A can be accommodated in B. So your A or the length of A can be called as unit, and the length of B that you are trying to measure can be called as a measured quantity. So in terms of A, you are trying to tell the length of B. It means B is 3 times as long as A. So A is the standard reference and B is measured in terms of A. Like that, there are various other examples. The actual unit of length is not just the length of the red bar A that we have taken here. You are already using it from lower classes. The actual unit of length is meter. Similarly, the unit of time is second, and the unit of speed is kilometers per hour. This is something that you see on the speedometers of your vehicles. On that dial there, it will be written at the center, kmph. It means kilometers per hour. That tells you how fast you are going on your vehicle. So these are the various units that we use in day-to-day life. Let us take up one more example to understand this. Suppose you have to find out the height of a person in your class. And suppose the value given to you is 152 centimeters. What this means is that in this measurement, you have a number and you have a unit. So this 152 is the number and centimeter is the unit. It means just like the red bar that we have taken earlier, a small division like this much is taken as 1 centimeter. And in this height of the person, there are 152 such centimeters. So once you find out the ratio gives you the value of 152 and the standard unit is centimeter. Collective information is given in this 152 centimeters. It means using the unit of centimeters, it is repeating itself 152 times while I measure the height of this boy. This is how we can undertake measurement. Now when we speak of a unit, any unit should have some qualities in it. Otherwise, you can't take length of any bar or any rubber band as one unit of length. It should have some qualities. Now, what are the qualities that a unit should have? The first one is that the unit should be well defined. So when we say well defined, you can't say that the length of my arm is equal to 1 unit of length, because as you grow taller and taller, the length of your arm will also increase. So can you choose that as a standard reference? No. And then suppose some of your friends who stay in some far off place like Delhi or Calcutta, they want to measure a unit of length. How can they call you there and check the length of your arm and use it? So the unit of any physical quantity should be very well defined. It means everyone should be able to understand it and use it properly. Second one is that the unit should be easily reproducible. It means if you mention the same conditions as to how you have defined a unit to your friends or other scientists, they should also be able to arrange that experiment there and they should be able to get the same unit. So a unit should be easily reproducible. It means there is no secrecy in that. You can't lock yourself in a dark room and say that, okay, I have decided a unit of length, now you use it, without telling them how you have done that. So it should be easily reproducible for everyone. The third one is that the unit should be unchangeable. Suppose if you use a unit that keeps on changing, in summer it has one value, in winter it has some other value, in a rainy season it has some other value. So how can that be taken as a standard? Because unit is supposed to be a standard reference. Therefore, the third important quality of a unit should be that it should be unchangeable. At this point, it is very important to understand the difference between a quantity and a unit. Quantities and units are not same. length is a quantity that you measure in terms of units, which can be meters or centimeters or kilometers. Similarly, time is a quantity, and the unit for time is either seconds or minutes or hours. There are various units, right? So quantities are what we are trying to measure, and the standard references for measuring these quantities is what is called as unit. That distinction should be very clear. Now, since quantities and units are not same and it is understood, let us go to the next aspects of units, that there can be various kinds of units. Why would there be various kinds of units? Because people started living in different civilizations, and earlier there was no communication between all these civilizations. That doesn't mean that science did not develop. Science developed independently in all the civilizations on various parts of the world, in various parts of the world. And since there was not much of a communication between them, each one started developing their own units. So it is because of the independent development of science in various parts of the world that we have different kinds of units. I'll give you one example for this. The unit of length. You know, there are so many units of length that the unit of length can be measured in meter, yards, inch, foot, mile, chain, rod, and apart from all this, you will find some local units also. If you go to a fruit market or to a vegetable market, or if you want to buy a garland, there they will measure length in a different unit. Next time you check that out once you go to a market. The unit of length used in finding out the length of a garland is different from any of the units that I have mentioned here. So various kinds of units are in use all over the world. But out of all the kinds of units that are being used everywhere, three sets of units gained importance. It means they were most commonly recognized everywhere. The three systems of units are CGS, FPS, and MKS. One similarity between all the three systems of units is they contain the same three physical quantities: length, mass, and time. All the three systems of units have the length, mass, and time as the most important quantities there. In CGS system, length is measured in centimeters, mass is measured in grams, and time is measured in seconds. Therefore, you get the name CGS. Similarly, in FPS system, the length is measured in foot, the mass is measured in pound, and the time is measured in seconds. Therefore, naturally, you get the name FPS. And then you have the MK system, where the length is measured in meters, the mass is measured in kilograms, and the time is measured in seconds. So these are the three important or the three widely recognized system of units. But then this is a very simplistic kind of a picture. When science began, or long time back, people were just happy cultivating food and moving around here and there in bullock carts, and they were happy with those lives. But then science developed, and from bullock carts we came to a level where we started using bicycles. The technology or the science used in making bicycles is more complicated than making a bullock cart. That is easy to understand and appreciate. But then bicycles were also not the end of the story. From there onwards, we went on to make aeroplanes. This is the first flight of the Wright brothers that you see on the screen. So from cycles, we went to making planes. That is also not the end of the story. From making planes, we wanted to make huge reactors or huge satellites. So naturally, as you can see, the science keeps on developing. It becomes more and more complicated, and therefore we say that it becomes more and more challenging also. So from there onwards, we started making robots which can help us in our day-to-day life activities. So suppose you are given a task of making a robot like this one. Will the three quantities, length, mass, and time, be sufficient to understand and make a robot? No. That is because you should first of all have a battery to run a robot. In battery, there are parameters called as voltage, current, and then there is electrical circuit here. For that you need resistance. Then the robot will have artificial eyes, in which actually there are two small cameras. Now cameras have some optics or light related functions in that. Therefore, length, mass, and time cannot be sufficient to understand all the science that we know and to make new machines that we have in mind. Now, in order to make a complex machine like a robot, The three quantities that I mentioned, that is length, mass, and time, may not be sufficient. You need more quantities. You see, these are the various quantities that we come across in day-to-day life from various aspects of science. So naturally, this caused a concern, a worry in the minds of scientists. They began to wonder as to how many quantities do we need in order to understand science. And then more important question than that was, is there a minimum number of quantities from which we can obtain all other quantities? It means by some method we should be able to figure out the least number of quantities by which I should be able to get this quantity, I should be able to get that quantity, and for that matter any other quantity. For that, there was a meeting of scientists from all over the world. And in that meeting it was decided that yes, there is a limited number of quantities from which we can derive all other quantities. This system of units is known as SI. And as you can see, there are 7 quantities listed out here: length, mass, time, thermodynamic temperature, current, amount of substance, and luminous intensity. So these are the 7 quantities, and correspondingly there are 7 units, and correspondingly there is a symbol for each unit. So the quantity is length, the unit is meter, and the symbol is M. Similarly, the quantity for mass, the unit is kilogram, and the symbol is kg. So you are almost familiar with all these quantities here, except maybe amount of substance, which is called as mole, or the unit for amount of substance is mole. You will understand about this particular quantity called as amount of substance in your chemistry classes later on in this year itself. And the last quantity is luminous intensity. Now, without going into the details of luminous intensity, you can just remember luminous intensity as something similar to the brightness of a body. So when the body is glowing with a lot of brightness, you say that its luminous intensity is very high. And when a body is glowing with a very less amount of brightness, like your bed bulb, then you can say that its luminous intensity is less. So luminous intensity is a quantity that is roughly related to the brightness of a body. So these are the 7 fundamental quantities. So what are fundamental quantities? Quantities that cannot or need not be derived from other quantities are known as fundamental quantities. And what will be fundamental units? The units of these fundamental quantities are known as fundamental units. And I will again help you recollect that in SI system you have 7 fundamental quantities, therefore you have 7 fundamental units. And if we look at a few examples of the fundamental quantities and fundamental units, then the quantity is length, the unit is meter. For the quantity mass, the unit is kilogram. And for the quantity time, the unit is second. But then as I told you, these are the fundamental quantities by which we should be able to derive all other quantities that we need in understanding all of the science that we do today. So from here, we go to what is called as derived quantities. Naturally, the quantities that can be derived from other fundamental quantities are known as derived quantities, and the units of derived quantities are called as derived units. Let us look up some examples for this. The quantity area. Area is measured as length into breadth. So you're deriving area from length, and the unit is meter square, because length is measured in meter multiplied by breadth is also measured by meter. Meter into meter gives meter square. So you are able to derive area from a fundamental quantity that is length. You could say that no sir, there is another important quantity that is breadth. Breadth is another name that we give to measuring length in another direction. That is what is called as breadth. So it's not a new different quantity. It is just a new name given to a quantity length that is measured in a particular direction. Density is given as mass by volume. Mass is kilogram and volume is meter cubed in the denominator. So if you write down the unit, that will be kg per meter cube. So density can be derived from mass, which is a fundamental quantity, and from length, because using length you calculate volume and the volume is used here. Similarly, speed. Speed is equal to distance by time. Distance is measured in terms of length or in terms of the quantity that is length, and the unit is meter. Therefore, distance is measured in meters. Time is measured in seconds. Therefore, the unit for speed is meters per second. So you see, this is how we can derive quantities from some other fundamental quantities. So we have seen what are fundamental quantities and fundamental units, and derived quantities and derived units. Let us then look at multiples and submultiples. Now, before we go to multiples and submultiples, I'll explain you as to why we need multiples and submultiples. We know that the unit of length is meter, and meter, as you know, is a fairly large quantity. Suppose you are required to find the thickness of the refill of your pen. Would you like to measure it in meters? No, because meter will be a very large value. You will try to measure it in a quantity or in a unit that is lesser than meters. That is called as a submultiple, centimeters, or even smaller than that, millimeters. That is also a submultiple. Similarly, if you are asked to measure the distance from here to Delhi, would you like to measure it in millimeters or centimeters? No. Then you will use either meters or even larger unit, that is kilometers. Notice that when I say millimeter, centimeter, kilometer, in all these cases, the word meter is constant there. It is only the prefixes that change. You get centi or milli or kilo and so on. So based on this, we can write some submultiples and some multiples. The first one that I'm showing you here is micrometer. That is 10 to the power of minus 6 meters. It means that is 1 by millionth of a meter, a very minute quantity. The thickness of your hair is roughly about a few microns or a few micrometers. So there you can't use meters directly. So you write it in terms of micrometers. Then the next unit is millimeters. You are already familiar with that. This is 10 to the power of minus 3 meters. That is 1 by 1000 of a meter. Then you have centimeter. That is 1 by 100 of a meter. So all these are submultiples. Then if you go to multiples, there is something called as the hectometer, that is 100 meters. Then there is kilometer, that is 1000 meters. So you can have submultiples and you can have multiples. There are about 5 or 6 submultiples and 5 or 6 multiples. I'm not listing out all that. As and when we come across these kind of multiples and submultiples, you will understand that multiplication factor easily. The next very important thing that we have to understand is that whatever quantity we are measuring, irrespective of the units that we use, the quantity remains the same. You can say that the length of the pencil is 10 centimeters, or you can say that the length of the pencil is 0.1 meter, but the pencil doesn't know that, right? Its length is whatever is the length. Therefore, whatever be the units that we use to measure a physical quantity, there are always ways of converting from one unit to another unit. And this conversion factor, a few of the conversions are what I am showing you on the screen now. There is no point in writing this down. There is no point in by-hearting all these conversions. In most of the cases, the conversion factors will be given to you. Then you would be required to do a sum or a numerical based on the conversion factors. So this is just to tell you that a unit of length 1 meter can also be represented as 3.281 feet, or it can also be written as 39.37 inches. So the meter can be converted to inches, inches can be converted to meters, and so on. So if this can be done for a fundamental quantity, it can be done for other derived quantities also. That is what is important to understand. Next, we look at the unit quantity relation. As I told you, we can express the same quantity in different units. So as we take smaller and smaller units, what happens to the number? Or as we take larger and larger units, what happens to the number? Let us look at example of that. The larger the unit, the smaller will be the value of the measured quantity. The quantity will be same, but the value that you get will be small. What does it mean? Suppose you have a length of 0.254 kilometers. So the unit here is kilometers. That is a very large unit. And the number is 0.254. If you measure it in terms of yards, yards is a smaller unit. Therefore, the number has now become 277.78. So the same 0.254 kilometers, if you want to write it in terms of yards, it will be 277.78 yards. So smaller the unit, the larger is the number. Then if you want to measure it in inches, inches is even smaller unit. Just about this much is 1 inch. So the same 0.254 kilometers, it will be equal to 10,000 inches. The quantity is same, but since the unit has changed, the number has also changed. And if you want to measure it in millimeters, it will be 2,54,000 millimeters. Again reinstate that the quantity is same. It is same 0.254 kilometers. But since you are measuring this distance in millimeters, the corresponding number will be very large. That is what we mean when we say that larger the unit, the smaller will be the value of the measured quantity. Now, based on all that we have learned, let us take up some numericals and try to understand the implications of that in day-to-day life situations. The first example that we look at is that the distance of Hyderabad from a particular place is given as 80 kilometers, as you see that on the signboard there. Then find this distance in miles. 1 kilometer is equal to 0.621 miles. So this is a very simple sum. If it is 80 kilometers, then it will be 80 into 0.621 miles, and the answer turns out to be 49.68 miles. See, kilometer is a smaller unit, therefore the number is 80. Mile is a larger unit, therefore the number is 49.68. Now let us look at the second numerical. A ship sailing from Chennai port to Kolkata port covers a distance of 780 nautical miles. Express this distance in meters. For this, you need a conversion factor from nautical miles to kilometers first of all. That is given. 1 nautical mile is 1.852 kilometers. And we already know that 1 kilometer is equal to 1000 meters. Therefore, this distance of 780 nautical miles can be written as 780 into 1852. So this product will give you the value in meters, and the answer is 144,560 meters. Notice that nautical miles is a very large unit. Therefore, again the number was 780. When you converted that to meters, meters is a small unit. Therefore, the number has become very large. It has become 144,560. Now let us go to the third sum. A satellite revolves around the Earth at a speed of 3070 meters per second. Express this speed in kilometers per hour. So here we can't guess directly whether it is going to be a smaller number or a larger number, because kilometers is involved and hours is also involved. There are two quantities involved here. So let us try to calculate this. We know that 1 kilometer is 1000 meters. Therefore, 1 meter will be 1 by 1000 of a kilometer. Why are we using this? Because what is given is meters and what we have to convert it to is kilometers. Similarly, 1 hour has 3600 seconds in it, because 1 hour has 60 minutes. Each minute has 60 seconds again. Therefore, the total number of seconds in 1 hour is 3600 seconds. Therefore, each second is 1 by 3600 of an hour. So if you want to write down 3070 meters per second in kilometers per hour, it would look like this. So 3070 meters per second is same 3070. Now this meters is converted to kilometers, that is 1 by 1000 of a kilometer. And then this one is 1 by 3600 of an hour. So the same number is now measured in kilometers per hour. And if you simplify this, this 1 by 3600 goes to the numerator and 1000 comes to the denominator, and this is how the number turns out to be. Therefore, 3070 meters per second is actually equal to 11,052 kilometers per hour. So this is how you can calculate the quantity in terms of different units when there are more than two or more than two quantities involved here. You write the conversion factor for each of the quantity. If it is in the numerator, you write it in the numerator. If it is in the denominator, you write it in the denominator. Then do whatever cancellations are to be done and you'll get the answer. Now let us look at the next example. The built-up area of a flat in an apartment is 1,650 square feet. What is the value when measured in meter square and in square yards? So we'll take up the first case out of that. 1 foot is equal to 0.304 meters. You need not by heart it. It will be given to you in the standard data. From this, you should be able to find out how much is 1 square feet. It means you square the left hand side, you square the right hand side also. So 1 square feet will turn out to be 0.0924 meter square because you have squared the right hand side also. So if 1 square feet is this much, then how much will be 1650 square feet? For that, you just have to multiply this and you get the answer as 152.46 meters square. Similarly, we can get the value in square yards also. For that, we use the conversion factor. 1 foot is 0.33 yard. So how much is 1 square foot? 1 square foot will be 0.11 square yard. Again, you just have to square the previous equation and you get this value. So if 1 square foot is 0.11 square yard, then how much will be 1650 square feet? That will just be 1650 into 0.11 and the value turns out to be 181.5 square yards. So this is how, if we know the quantity in one system of units, you'll be able to get the quantity in another system of units. Now let us summarize what we have done till now. We have seen what is measurement. But then why do we have to do measurements? Measurement is required to compare quantities. We have seen that in numerical examples, to find out the relation between different quantities, to understand new processes scientifically, and to communicate our understanding, and all this will lead to the development of science and technology. This is why we need measurement. And then measurement itself is the ratio of quantity to a standard reference. The standard reference is itself called as the unit of the quantity, and then there are something called as fundamental units which cannot be derived or which need not be derived, and then there are units which can be derived, which are known as derived units. And how many fundamental quantities are there? There are 7 fundamental quantities. And then we know that whatever units we use, the quantity being the same, we should be in a position to convert from one system of units to another system of units. So basically, we have seen what are units, what are quantities, and the relation between them. In the next class, we will go into the detail of measurement of the first fundamental quantity, that is length. We will see how we can measure length from different instruments, the advantages and the disadvantages of each kind of measurement. Thank you very much.